variables. Now we have 30,001 variables. What do I have to do?
Change 30,000.
We have to add 2 more lines, and then we have 30,000 lines to change, because each one of those will need one additional comparison, right? That's a lot of work. So for the sake of being lazy, so I don't have to do a whole lot of stuff when I need to deal with a larger number of variables, I want to have arrays. Okay? Now I'm not going to explain the notations just yet. I just want to show you or have some exposure so that you understand why arrays are useful. Okay? Using arrays, the same result can be achieved using the following algorithm. What we'll do is we'll say I gets 0, while I is less than bar A bar do. If Z is less than A bracket I, then Z gets A bracket I, and if I gets I plus 1, and while. This is also a very good example of what happens without indentation. The code gets a little difficult to read. It's not like you cannot read it, it's just more difficult. Because you can still see if and end if here, while and end while here. This is after the end if, but before the end while. So you can still kind of tell what to do next, but it's not easy to tell anymore. It's not nearly as easy with as compared to with indentation. So it's a good illustration why we want to have indentation. Whenever you write programs like this. Now this one is with indentation, and I'm still missing. Okay, there we go. So with proper indentation, it is a whole lot easier to read because things just quote unquote they just line up. Okay. All right. Now, do you think I need to change this algorithm at all if I have one more variable to deal with? Nope, does not change. This algorithm will work with 1 element. It will work with 10 elements. It will work with 1,000 elements, 10,000. It does not matter. The amount of time will change. Okay, it will take more time to find the maximum of 10,000 elements as compared to 1. But the length of the program itself is constant. It is always just this long. Okay, so that's one reason why we need to have arrays, because arrays gives us the possibility of writing algorithms that are much more compact and much more scalable. In other words, when you deal with more data items, you don't have to make any changes to the algorithm itself. So are we okay so far with the rationale behind using arrays? Is that good? Okay. Yep.
Could you draw out how that works?
I will explain the notations.
Get
Yes, we will get to the notations. At this point, all I'm interested in is to show you what it looks like, and then we'll go back and just explain, the way it works, how it works. So let's go back into the notes. And we are now into arrays. So we have just explained the why, because without arrays, algorithms are not very scalable. Okay, just adding one more variable, I have to make a lot of changes, and it's just a big hassle to begin with. So now we're trying to explain what is an array. So you can read this part, you should read it before the class, but I can explain it too. The variables that we are dealing with, like x, y, z, and so on and so forth, each one is like a container, like a cup, a mug, or a glass. Okay, it can contain a certain amount of fluids or other content, and each one is individual. Okay, so if I have 3 variables, x, y, and z, you can just kind of imagine there are 3 containers, and each one has a name. Okay, each one is labeled by its name, x, y, and z. And because each one is just named by its name, if I want to refer to each one of these, I have to use the name. There's no other way to say this container instead of the other container. And that's the limitation. An array is interesting because an array is like a box. So if I have an array A, it is just like having a box, and the name of the box is A. Inside the box, what do we have? Well, it depends on how many things you want to contain in the box. If I want an array of 5 elements, then it is the same as saying the box is containing 5 containers. So now we have these 5 containers inside a box. Well, that's nice packaging there. But how do we say that we want this mug or this container instead of that container? Containers inside a box are no longer named. They don't have names inside the box. Inside the box, they are numbered. Okay? They are numbered from 0 to 4 in this case. So we have container 0, container 1, container 2, container 3, and container 4 of box A. Okay, so A is an array. Inside the array, in this case, we have 5 elements. Each element inside the box is numbered. Okay, they're numbered from 0 using consecutive integers all the way up to n minus 1, where n is the number of elements in the box. Are we okay so far? Okay. So in this case, if I want to designate a particular container, this is why we use this square bracket. The square bracket is called the indexing operator. It is basically using whatever integer that you are using between the square bracket to specify which container inside box A do you want to refer to. Are we okay so far? So instead of having a name per container, we have a name for the entire box. Each container inside the box is no longer named. Instead, it has a number. The number goes from 0 up to the number of elements minus 1. Is that okay? Okay. So the flexibility is not coming from the fact that they are inside the box. The flexibility comes from what can we use inside the square brackets. As it turns out, it does not have to be 1, 2, 3, 4. It does not have to be a constant. It can be any expression that gives you an integer, and the integer is within the range, in this case, from 0 to 4. That gives arrays the power because instead of giving a name to specify each container, you can use an expression, and the value of the expression will basically designate a particular container inside a box. So let me just write it down here because I don't think that part is actually in the notes here, so I should write it down here. The flexibility of using arrays is due to the indexing operator. In other words, when I use a square bracket dot dot dot, the dot 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 can be any expression that evaluates to an integer from 0 up to the number of elements in A minus 1. Yep.
I was wondering, the expression is like Visual Basic C and Java. You get to put an expression between the brackets. If it just comes out to be an integer, the syntax is correct, or do you have to convert it to an integer first from an expression?
It depends on the language, but in most languages, it is implied that the expression has to be an integer expression. So the result of the expression should be an integer of some kind. Okay. So do we have any questions at this point? I'm just kind of summarizing, what I said. It's basically the square bracket notation is the flexibility. This is why arrays are so useful. Okay.
Why line? There's kind of absolute value there.
That's not the absolute value.
Doesn't mean it's the determinant.
It's not the absolute value.
I know, but is it the determinant?
It's the number of elements in the array. Yeah. So I'm switching back to the notes here. So inside the notes, it basically says all elements in an array must have the same type. It is not very important at this point, at least in this class, to talk about types, so you can just kind of ignore that for the time being. Each element has an index. In other words, it has a number that identifies itself within the box. The index of the first element is 0. In other words, we start to count from 0. Now, does it seem odd to you that we are counting from 0 instead of 1? No?
It's a math thing.
It would have bothered me the first time, if I were taking a programming class. Why are we counting from 0 instead of 1? I mean, because when we count stuff, we usually count from 1, 2, 3, 4 instead of 0, 1, 2, 3. And the reason why we count from 0 will not be clear until you take assembly language programming. Okay? Because in assembly language programming, then we'll actually try to see how do we come up with the address of a particular element in an array. And then it will just suddenly be clear, it makes sense why we are now why we have been counting from 0 when we deal with indexing. But until cisp300 assembly language programming, it may not be clear to everyone why we count from 0 instead of 1. Okay? So indexes must be contiguous. In other words, you cannot jump around. You cannot skip every other number. They have to be contiguous. Now this part relates to the question that was asked earlier. What is the bar A bar notation? In mathematics, it means absolute value. But in this class, bar A bar means the number of elements in an array. Okay, that's the meaning of this operator, at least in the context of this class.
In math, it's determinant.
It's also the determinant and also the absolute value, right?
What's indices?
Indices. What?
Indices.
It's the plural of index.
Indexes. Indexes is the plural of index.
I just know what it was.
Oh, okay.
When on the bars you get the amount of elements in an array, does that return the value that's 0 based or 1 based?
It's the number of elements. So when you have, let's say, 5 elements, it returns 5.
Okay.
Yep. So it returns the actual number of containers inside a box, not the index of the last box, the last container. Okay. Any other questions? Okay. If there are no questions, we'll just keep reading. The last element in an array A has an index of bar A bar minus 1, which kind of answered your question as well. That's because we are counting from 0. An element with index I in an array A is represented as A bracket I. That basically all it is saying is the index or the stuff that goes between the square brackets. They don't have to be a constant. They can be any expression that returns an integer value. And that's why it is so useful, because now instead of having your program to predetermine which element you want to access by a constant number, you can now use an expression, maybe a huge long expression, to compute the index that represents the container that you want to access inside a box. And that is the flexibility. Each element inside an array behaves just like a variable on its own. In other words, there is no particular rule saying that container 0 has to have the same amount as container 1. They're completely independent as variables. Okay? Yep.
Can a container hold expression in it? Can it or
No, not an expression, a value. Yeah, because each one is just a variable on its own. It's just that it has a funny name. A bracket 0 is the name of this container. Yep.
So on the so it has an index of A, right? I don't know, absolute of A, 1 by A, on A bar, so it's like that.